Welcome to the Gardien Group Podcast Series. The Gardien Group, providing extraordinary solutions to today's exceptional problems.
Hello, podcasters. Welcome to another episode of the Gardien Podcast Series. I'm your host, Todd Kolmodin of the Gardien Group, along with Rick Meraw, our Group VP of Quality and What is it, Rick? Quality and R&D. That's it. Sorry about that, folks. Today we're going to talk about process versus work instructions, what a process is and how that's compared to work instructions. And first thing that I want to talk about, well, first, hello, Rick. Welcome to the podcast.
Hi, Todd.
Okay.
Thank you for allowing me to join you again today.
Okay. All right. The process. So when we talk about a process can be thought about as looking at a group of tasks that all come together for the intended result. What we're looking at is an overview. And these are all the steps combined, and these could be like building a circuit board. It could be building a house. They could be testing printed circuits, even driving a car. I mean, all these different tasks, starting the engine or building the foundation, or all these are different steps that all combine in the process to come up with what's called, your final result. So when we talk about processes, what we want to do when we want to develop one of these things is we want to look at certain items. And one of those, before we even go at it, we need to predefine what our goals are, what our outputs are, what do we expect from it, and what kind of requirements. So this might be, we're going to build a circuit board, and we have all the way back from image exposure and strip and etch, and then lamination and drilling and plating. Each one of those different pieces of this process may have its own set of individual instructions, which we call work instructions, which Rick will go over here in a little bit. So we also, when we want to do a process, we need, from an engineering standpoint, is we need to evaluate space requirements. And this should to optimize the flow, make sure the environment is what needs to be there. We need to evaluate things like what kind of air is necessary if you need it, what kind of power is necessary. If you have any kind of chemical activity of solvents or anything, what kind of venting needs to be done to make sure that, nobody gets hurt. Or that's the big thing, is having your process able to function as cleanly as possible without having any parts or problems. And if that process is part of a larger system, you need to evaluate your upline and downline handoffs. So when you get product or you pick up the process from a department, you need to make sure that the handoff is clean. And same thing if you're in the middle and you have a department that you're handing off to, you need to make sure that any constraints you have are alleviated so that it makes it much easier.
Yeah, that you said that right, Todd. One of the biggest weaknesses we have in a process is always the handoff from one position to the next position, whether it's a different team 1 to team 2. It's always, if there's issues, I know you have this from your experience too. If there's issues, it's always in that handoff, pass off, move down the process. It's always in that step.
Absolutely. And, both of us have been doing this for quite a long time. And sometimes we have to step back and talk to each other and kind of practice what we preach, because that's exactly what happens. And sometimes when we're making a process or new equipment comes in and you need to integrate that into your group or other processes, instead of just assigning it to one guy or girl to, make this all happen, it's great to use a group approach, because when you have many minds together, all the input is really valuable. Sometimes people can come up with ideas that, even the smartest guy not even, thought about it, and somebody just comes up with it, and it's a great idea. So, I mean, Rick, don't you think, we should have, when processes are being developed, you should assign them to a group and not just a person? What do you think?
Yeah, a team of people looking at the entire process always makes a much more robust process rather than one person or two people going at it. If you have a whole team, especially if you involve the people who are doing the day-to-day activity, if it's something related to a process that's done in a manufacturing or a service bureau, a team of people looking at it, it makes a more robust process when it's all said and done.
Yeah, absolutely. I mean, that's the whole idea, getting the group involved, because, us being higher up quality people in engineering and stuff like that, engineers can be dumb. I'm going to be, sometimes I'm going to be one right here to say, everyone can be wrong. I can be wrong. And I have many times. Smart people can be wrong. We're all wrong some of the time. That's a quote from Elon Musk.
Very true, Todd. For example, I took for granted that one of our team members simply mounted something onto a machine properly, right? And that it would not short to ground. We're doing an electrical test, of course, in this particular example, that it's not going to short to the ground of the machine. It's a PCB testing. And go figure, it was a big copper plane, and of course it was shorting to the ground. And I didn't believe when the engineers were telling me that it's got to be shorted to the ground. I said it can't. It's got to be a current problem. And we went back and forth for a few minutes, and finally, we were none of us were on site. We finally got someone in house on site and take a look, and yeah, it was shorting to ground. So it was a simple problem. They know, they just forgot that the board can short to the ground, machine ground, and cause a problem. So and they're usually simple mistakes, right? Simple things.
Yeah.
But everybody makes it. I made the mistake of believing in the team members 100% without double checking. I do that quite frequently. Most of the time it's right, but sometimes it's wrong.
Yep. And I stand to be the first one to admit I've done the same thing, where my mind says, and on paper, and developed it, and that can't be wrong. And you go out and look at a practical application, and oops, you missed that. Interesting. So anyway, when you're, good process, don't forget the process. Make sure that you develop it strong. Use all the points and people that you can. And then once you get that, test the process out. Make sure that it does work like you had designed it. Get people involved. And also, if you put different checks in your process, and that's for debugging purposes, always remember to go back and review that, because if you're not seeing failures or your acceptable limits are being made, go back and look at that chip and make sure that if it really is needed there, or if it's just there choking the system cycle time. So that's a great thing that I learned that we should always do. And then try to optimize the best you can. If you can remove some steps and still get the intended result, that's a great thing too. And always when we talk about processes in this day and age, the big thing is automate, automate, automate. If you have the ability, if it's the type of process, I mean, a lot of human processes sometimes can't be automated, but like Rick mentioned, electrical tests with the equipment, and a lot of the stuff like building printed circuits and all that, there's a lot of automation that's available. And that's, striving to the future. That's where we're going. So I'm going to let Rick talk a little bit now. I talked about the process. We talked a little bit about the process overall. And then the next thing is within the process, if you're doing individual steps, that's where we come into when we talk about work instructions.
Thank you, Todd. Yeah. So the way we've set up our work instructions, if we have a dedicated flow that we use for our work instructions, we always have certain sections labeled. We do, just before I get into the details that we're presenting there in the pictures, we have a couple things where we set some objectives. What is the scope, right? We need to know what we're doing. So what's the scope? And then we also do, what's the training objectives? So, okay, it's fine to make work instructions, but if people just read it, they need to understand it. So maybe the training objectives, we put in this section, we put some bullet points about what they should be getting out of the training or the reading and the operation of this particular work instruction. And it can be as much as testing.
Absolutely. I mean, yeah, go ahead, Rick. I didn't mean to interrupt.
But
Well, so like Rick said there, when we start talking about a work instruction is of a set of tasks and information to perform, the task that you're assigned to, or uh, say we're making widgets. This is how to put paint on the widget or whatever. So you want to have your predefined goals, like Rick said, and your outputs and requirements. Like he said, we need to define the prerequisites, which means what are we going to get out of this? And that is in the scope, what you should know when you're done. And then you should be able to use either a practical review and also a documented information review. Some of us learn by different means, right, Rick?
that's correct. Now, the work instruction is meant to be there as an assistant. More of the training and awareness is done practically on the job, at least in our operations, Todd.
Yeah.
We have some fixed areas where we define, okay, this should be for this should be for that, just like a whole gauge or some sort of no-go or go gauge, where the block goes in this way, it'll fit. If it goes in the other way, it doesn't fit. So when we write our work instructions are similar in that way. So it's defined areas where maybe they place the untested. If we talk about electrical test, maybe where they place the untested boards, to where they place the failed boards, to where they place the passed product, the electrically good product. And one of the things that everybody needs to do is take a step back and look at, is it the most efficient way? One of the things that Todd mentioned in the beginning was environment and space and things like this. And it's very important. If you're taking work instructions for a dedicated process, and it's something that the person's kind of monotonous, if it's a monotonous process, you want to do something that makes the operator stay alert, right? Because if they're doing, they will build up speed doing the same process over and over and over again, or the same step over and over again even. They will build up accuracy and speed, but they need to pay attention to the fine details in case something abnormal appears. And one of the things that we do is we get a team there and we watch some people working through the process, and we overlook, and that whole team overlooks. And then they come up with potential risks involved in each particular step that person's doing. So let's take something, for example, taking a board from a grid tester that was passed, and then where to put the board on the machine onto a pile, because everything goes in a dedicated spot. When did they do this? When did they put the electrical test stamp on? What did they do next? All this particular thing is looked at via the team for, are they missing anything? Do they have adequate tools? Do they evaluate the results? All this is done with a team watching over. And I think, Todd, that really makes our work instructions very robust overall. And we've been building some of them for a long time, some of the basic ones, but some of the more advanced ones where we get into special testing for high pot, or we get into 4-wire Kelvin, things about 4-wire Kelvin is especially delicate in the beginning, because not a lot of people are able to calculate the resistance of the trace or hole, depending on what we're doing. So that whole process step or work instructions to generate what we call a master or do type of learn is very delicate. We need to make sure it's done right. If it's not done right, we could have some sort of error down the process.
Absolutely. And another thing that you mentioned, the work instruction or the task that might be monotonous. I mean, we've run into this before, and it kind of dovetails into what I talked about a little bit before about automation. I mean, sometimes if you were to be an operator at a grid tester where you're dealing with moving boards from left to right, and you're literally talking about testing thousands of boards at one time or over the course of your shift, or as you sit there, the monotony gets pretty great. And so what we found is that during something like that, you need to evaluate, when we talk about environment and such, You need to interject or get a break involved for the operator to step away from the machine, focus your eyes across the room. It may be, a normal break for the employee, but, get them away from the task so that their mind can clear. Because once you get into that monotony, you just kind of zone out. And that's when Rick was talking about the board from the left to the right. If it fails, does it go here, or when to stamp the board? And you're get going for a long period of time, it can be really monotonous. I totally agree. So I think, what we really brought to you today is a few takeaways. When you're developing a process, you want to look at that when there's multiple steps going to be involved. Look at from high altitude. I kind of use the flight level of 100, the 10,000 foot level, so that you can see all the different pieces, how they're supposed to go together, so that when you develop work instructions, you can focus more on detail and how it affects the others. I'm sure, Rick, you would understand and agree with that.
Yeah, 100%, Todd. Everything kind of flows together. And we also need to have, if you're doing a process from start to finish, you want to have some sort of small measurables that are administratively easily can be captured to see if there's anything wrong with the process itself. You can go deeper, but some of the processes don't require big analytics and things like this. But we always got to have some sort of way of measurement in there. I know that we mentioned here in the work instructions, we even go as far as writing a mini exam for work instructions, or some sort of just person-to-person comparison of the knowledge level.
I agree, and that's the one thing that each company has a different way, but you need to somehow, if you're an ISO registered company, compliant, somehow you have to have some kind of system in place to evaluate employee effectiveness and training, and the only way to really do that is have some record that they went to a class or they took a class, and some way to show proficiency. Well, we were talking about getting the operators involved in work instructions to make sure that they're correct and not missing anything, because let's face it, we're human. Operators, they'll find the shortcuts if it's there. And, sometimes the shortcut may be a great thing that you had too many steps in the work instruction, or conversely, it could be they're skipping a step or something that does have a adverse effect on the outcome of the task that you're performing.
Very true. Very true, Todd.
So, and the other thing that Rick and I both do is that we try to do as much as we can is we want to recognize your teams when they're getting involved, because there's a lot to say, to somebody, to say, hey, thanks for helping. Your input was valuable. Not just to say it, but, we don't all know everything, and using the team approach and then recognizing your team and using the input effectively, if it's good, it gives the process and work instruction and the overall output of what you're trying to do a better shot as being successful a higher percentage of the time, and it gives the operators a good feel of ownership. And that's about all I have, Rick. If you have any closing comments today.
No, but the work instructions are an important process. I know there's many companies out there that don't like to have work instructions, and it's kind of really a type of option now in some of the ISO registrations to have it fully documented in details. But sometimes having more detailed instructions maybe means a little bit more maintenance once in a while, but it also makes a robust process run smoothly. I know for us, Todd, we're a quality-oriented operations for service bureaus, and we're judged on quality. If something goes to the customers and it comes back and it's defective, we're the ones that get in trouble. It costs us money too. We're better off to put the money up front rather than paying for product and potentially losing that customer later on down the road. That's why we focused a lot of time and a lot of people in teams generating our work instructions.
I totally agree. And like you mentioned, with our service bureau activity, where we are having customers all across the gamut, from aerospace and military and commercial and medical, I mean, the traceability is one of the things. And, when you go back and have to review something, if you unfortunately have some type of error, having the traceability of work instructions is the step there. Traceability of operator performance and competency and things like that. And plus, another thing, this is a little out, it could be a totally different subject of some time or another. But, if you are keeping track of all the steps, either by electronic media or something, so that you have traceability to go back so you can answer the 5 whys, So with that, we thank you for joining us again on another one of our podcasts. If you'd like to drop a line or have any questions, go ahead and do so. Send it to info@gardien.com. That's info@gardien.com, or you can visit our website at www.gardien.com. That's gardien.com. Thank you once again for Rick and myself. We'll see you on our next podcast.